All right, let's go over your warm-up. We needed to write a rule or an equation to relate the diagram number to the number of squares. So to do that, we want to start by making a table with our independent and dependent variables. X is going to be our diagram number. That one's independent of Y, our number of squares. So if we look at diagram number 1, there's only one square. Diagram number 2 has 3. Diagram number 3 has 5. And diagram number 4 has 7. To be able to write that equation, we have to see how each one of them is related. The independent variable is increasing by 1 every single time, positive 1. The dependent variable is increasing by 2 every single time. Okay. We always want to start our equation with y is equal to mx plus b. The ratio of how each variable is changing in comparison to one another is m. We can call that our slope. New word for you, slope. So when we look at our y variable, we're going to put the y over the x as our ratio. This keeps changing. We're adding 2 every single time, so that's a positive 2. Every single time, our x value is increasing by 1. We said that we could use 2 as our slope because that's for every single time our independent variable or the number of diagrams increases by 1, the number of squares is increasing by 2. So it's double that. So we put our y over our x, and now we have our slope of 2. So we can plug that into our equation for m. Y is going to be equal to 2x then plus, and we have to fill in that last part for b. We talked yesterday about a little trick to find that 0 term. We want to know, well, using our pattern of plus 2, plus 2, plus 2, what plus 2 gives us 1? We know that negative 1 plus 2 gives us 1, and negative 1 is the value of y when x is equal to 0. That is our value for b. When x is equal to 0, we want to know what is that y value. And in this case, that one is negative 1. So that's what we plug in for b. We can simplify that equation saying y is equal to 2x minus 1 instead, because adding a negative is the same thing as subtracting 1. Now to make sure that we actually did that correctly, we can use one of our ordered pairs. Let's use the ordered pair 2, 3 from our chart, from our table. 2 is our x value, 3 is our y value. So when we plug it in, we're going to have 3 is equal to 2 times 2 minus 1. We know 2 times 2 is 4, and when we subtract 1, that does give us 3. Because this worked, we know that our equation is correct. So today we're continuing to work with a few examples of how to model functions using rules, tables, and graphs. Let's see another example. This time we're talking about mountain climbing. We need to describe this using words, an equation, and a graph. Let's start with the words. We need to see how much each one is changing in comparison to one another. The number of hours climbing keeps increasing by 1. And then the elevation increases, so we need to figure out how much it increases by. And it actually increases by a positive 92 every single time. So when we write that in words, we can say that as the number of hours increases by 1, the elevation increases by 92. Now we've used words to describe that table and how each variable is related to one another. Now let's write an equation. We know that we need to find m, the slope, and b. So to find the slope, we want to see, well, how much is y changing in comparison to x? We put the y over x, and we have 92 over 1. So our slope, that m value, is going to be 92. So we plug that in, and we have y is equal to 92x plus some number. In the warm-up, we had to find what y was equal to when x was 0. This time, it's given to us. When x is equal to 0, y is 1,127. That's our b value, 1,127. And again, we can check to see if this is correct by plugging in one of the ordered pairs. Let's use the ordered pair, 2 and 1,311. We could have picked any one of them. Let's use that one. So we're going to plug in 1,311 for y. We have 92 times then 2 for x from that ordered pair in our table. And then let's simplify it. When we do that, we get 1,311 is equal to 184 plus 1,127. When we simplify it even farther, we get a true sentence of 1,311 is equal to 1,311. Because of that, we know that this equation of y is equal to 92x plus 1,127 is the correct equation. Our final step is to make that graph. When we look at our table, we see that all of the values are increasing. As the number of hours increase, the elevation also increased. So we know that our graph needs to be increasing. Let's make that graph. We want to start with our axes on both sides. We know that this is x and this is y, and then it keeps on going. We also know that the number of hours climbing was our independent variable, so that goes on our x-axis. And that was counting by ones, so we can count by ones on that scale. And we'll number them as well. 1, 2, 3, 4, 5. Our dependent variable was elevation in feet. So that'll go on the y-axis. The elevation, we want to look more closely at that. It was increasing by 92, but we're not going to use that as our slope because we want to use a number that's easy to add without having to write down it every single time. 92 plus 92, then add 92 again. We don't want to do that. So let's pick an easier one. And we have to get all the way up to the thousands because all of our numbers are in the thousands and they continue to increase. So a better number to count by in this case would maybe be like 250 or 500. So let's try that 250. If this is 250, then we have 500, 750. Ooh, that was a little high. 1,000. 1,500. And 2,000. And that's plenty high. So now, let's plot those points. To do that, let's start with our 0 and 1,127. 0 is going to be on this line, 1,127. If this is 1,250, 1,127 is going to be right about here. Then we go up to 1,219 after 1 hour. That's going to be a little bit closer to that hash mark for 1,250. After 2 hours, now we're up to 1,311. So we want to be above that, right about here. And after 3 hours, we're all the way up to 1,403, just a little bit below that 1,500. This should create a straight line for our graph because we're working with linear functions. If it doesn't create a straight line, then you know that one of these points is probably incorrect. If one's not on the line super far away, then you want to double check that you graphed it correctly. Use the grid lines on your graph paper to help you make them as accurate as possible.